All right, so continuing on to question number 7 here. More Lewis structures, although it kind of structures on a theme here with all sulfur oxygen compounds. And I think in this case, we're actually going to have to look out for resonance a little more than we did up in the first bank of Lewis structure problems. But let's see what pops up here as we tackle these. So starting with A, 1 sulfur, 2 oxygens. So sulfur is less electronegative than oxygen. Let's put sulfur in the middle. Both are from column 16, so each would start with 6 valence electrons, so that would be 18 that we have here. Now we used 4, so 14 are left, and we can use 12 of those completing the octets on the oxygens. That would leave 2 electrons. They would have to go on the sulfur in the center. Now, looking at the molecule at this point, right now that all the electrons are in there, we need to share some electrons to get the sulfur up to satisfying the octet rule. But it might be helpful here to think about sulfur in the middle of a molecule is possibly going to have an expanded octet. So if we do, right, add 1 double bond here to make sure that sulfur has 8 electrons, we should probably recognize that that's not the best in terms of formal charges. We did get this oxygen to a 0 formal charge, 6 minus 2 minus 4. And we got the sulfur to a better position by getting it to satisfy the octet rule. But at this point, we still have a negative over here on this oxygen. 6 minus 1 minus 6 non-bonding electrons is a -1 formal charge. Sulfur here would be 6 minus 3 bonds minus 2 non-bonding electrons would be a +1. So we don't just want to stop at the octet rule, we want to share also from the other side and add another double bond because that will even out the formal charges so that it's 0 for all of the atoms involved. And that does have an expanded octet for the sulfur, but sulfur is big enough that that is just fine. Now, depending on when you're reviewing here, right, for the second test, we generally are not going to talk about the shapes and the angles, right, but this would be 3 sets of electrons. This would be a bent or angular shape, right, and we'd anticipate the angles here being about 120 degrees. But usually that's not going to come in until the final. So maybe you want to look back at your Lewis structures here to practice for the final, right? If that's the case, think about the shapes and the polarity as well. Now, if we add another oxygen, right, how is that going to affect the structure? Well, sulfur is still going to be less electronegative, so we should still start with sulfur in the middle here. Total electrons now would be 24. Right? That additional oxygen would bring 6 more. We used 6 already. We can use the remaining 18. 24 minus 6 is 18. The remaining 18 to fill the octets on the oxygens. So that would be all the electrons. We'd get all the electrons in there without putting any extra electrons on the sulfur. But we should notice here, sulfur does not satisfy the octet rule. And in fact, if we think about formal charges here, before we've completely looked at the octet rule, we would notice this. At this point, we have a +3 charge on the sulfur, negative on each of the oxygens. So what we really want to do here is make 3 double bonds. So if we make double bonds to all of the oxygens, that will get all the atoms down to 0 in terms of their formal charge. All the oxygens will be 6 minus 2 minus 4, and the sulfur will have 6 bonds now, and it'll be 6 minus 6. We'll also get to 0, right? And that would give us a trigonal planar geometry there for that sulfur. Okay. Now the last 2 are ions, so we'll have to account for those additional electrons. So if I move over here to try to do C, that's the sulfide ion, so SO3 2-. So we're going to start the same way we did for B with sulfur in the middle and oxygens surrounding. And in fact, maybe when you did number 6, you already drew the sulfite ion as part of trying to figure out what that sulfurous acid, which is based on the sulfide ion, would look like. But let's go through it all again. That skeleton, 24 from the atoms, an additional 2 electrons from the charge. There would be 26 electrons here. Now we used 6, but that means 20 are left over. So that means when we put 18 on the oxygens, there'll be 2 left. And those 2 are going to have to go on the sulfur, right? And that, of course, is what we saw up here. Now, in this case, since sulfite is our final answer, the things will be a little different because when we look at this structure, right, the octet rule is fine, but we can minimize formal charges. At this point, it's negative on every oxygen and it's positive on the sulfur. And that means to minimize formal charges, we want to make one double bond, right? So one of those oxygens will share a pair of electrons to the sulfur. But in this case, since we're looking at the sulfite structure, we don't know which one would be the one. And in that case, we should do all of them. So we should do 3 different drawings here where the double bond is formed between each of the oxygens and the sulfur. So each oxygen in one of the structures will be where the double bond is. We should connect all of these with resonance arrows, like so. And don't forget to put in your electrons. The oxygen that made a double bond will have 4 non-bonding electrons, or 2 pair, if you want to think about it in pairs. The other oxygens should have 3 pairs, or 6 non-bonding electrons, and that should be the case for every one of the structures, right? And it's not an uncommon mistake for people to put 6 on the wrong oxygen. You put 6 on this oxygen with a double bond and you violated the octet rule, and oxygen is just not big enough for that to be a reasonable structure. So be careful about getting all your electrons in there, but make sure they go into the right positions for your final structure. So you need to see all 3 of those in order to have this structure correct, right? And if we think about this a little bit, right? If we look at one bond, the bond pointed up is the one I'm going to pick. Double bond in one case, single bond in the other 2. That means 4 bonds spread over 3 structures. So the real sulfite has a bond that's in between a single bond and a double bond. It's about a bond and a third. As far as charges, the negative charges are on the oxygens, but they move to different oxygens in different structures. So again, just picking out one oxygen, it's neutral in one structure, negative in the other 2. That's 2 negative charges spread over 3 structures. That's a minus 2/3 charge on each of the 3 oxygens, which adds up to the total -2. Okay, part D here, the last one is sulfate, SO4 2-. I did not really leave myself enough space, so I'm just going to go to a blank page here for sulfate. We're going to start in a similar fashion as we did the other ones because sulfur is less electronegative than oxygen. It's a better share. It should go in the middle, but now we have 4 oxygens to kind of array around it. Sulfur is 6, each oxygen is 6, so 5 of those atoms would be 30 electrons, an additional 2 for the charge, so we should be thinking about having 32 electrons in here before we start looking at the other aspects of the structure like the octet rule and the formal charges. Now, we made 4 bonds, so we used 8 of those electrons already. That's 24 left, and that's just enough to put 6 on each oxygen, so we can complete the octets on the oxygens with our remaining electrons. Okay, and then we can start to analyze the structure. Now, the octet rule looks great for this structure. Every atom has 8 electrons, so that's good. But don't forget, we want to check formal charge. So all those oxygens have 1 bond and 6 non-bonding electrons, 6 - 1 - 6. That's negative for each of the oxygens. Okay, and since we only have a -2 charge overall, that's probably not good. But this sulfur in the middle, 6 for sulfur's valence electrons minus the 4 bonds, that's +2 for the sulfur. And that means we want to make 2 bonds. We make 2 bonds to the sulfur, then it'll get to 6 bonds. It'll have a 0 formal charge. That will also eliminate 2 of the charges on the oxygens, right? But this, of course, is a resonance situation. We want to do every possible combination of where we draw those 2 bonds. So we want to draw out, let's see how many structures that will take, right? We could have both bonds kind of top and right, right? And if I stick with the top and then move around, that'll give me a set. So top and bottom, top and left for the double bonds, right? And then what about to the right? I did right with top. I could do right with left. And I could do right with bottom. And that would leave one more, which would be left. We did 2 with left already. So we did left and top and left and right. If we do left with bottom, that will be the last possibility. So we'll actually end up with 6 different structures here, right? And I haven't even put in the electrons yet. We would want to go through and make sure we get the right electron dots on all of these. So we'd need 4 more for each oxygen that's part of 2 bonds, 6 more for each oxygen that's part of just 1 bond. But all of those should be in there if this pops up on your exam. And there certainly will be some resonance on your exam. I don't think I would want to grade this one because there's a lot of dots that I would have to be worried about checking. But there could easily be some with just 2 or 3 structures that would be a little friendlier for you to draw as well as for me to grade. So don't forget your electrons. It's really not the right structure without the electrons. And we should also have resonance arrows, right, all through, showing that these aren't different structures. These are all the resonance structures that describe the one structure that goes with the sulfate ion, right? And in this case, it's about 1.5 bonds between each sulfur and each oxygen because there's 3 double bonds and 3 single bonds. So that's a total of 9 bonds over 6 structures. That's 1.5 bonds. And there's actually a half negative charge on each oxygen. So any particular oxygen is neutral in 3 structures and negative in 3 structures. So half a charge on each oxygen. Okay, we'll break the video there. And I think there's one more page. We'll come back for the last page of the practice test.